Our mini lecture today is on Module 5, the brain, and this is a major part of our course of psychology. Our psychology course is based around if you know how the brain works and how to take care of yourselves, you're doing pretty good. And we're going to be looking at the brain. Now, you may look at this picture and say, golly, what a big brain. I actually want you to do something right now. Take your hands, literally, take both your hands, put them up in front of you. Make both hands into a fist. Put both fists together. Look at it. This is actually the size of your brain. You may say, ooh, it's pretty small. Actually, that's pretty big for many mammalians. Okay? But we're going to look at the brain and what is actually in the brain and how it works here in the different parts. So our first thing we're going to look at is a quick little case study on Phineas Gage. Phineas Gage's picture is to the right, and as you can see, the big thing he's holding in his hand is a railroad spike. The railroad spike went up through his head, whereas you can see in the picture on the left, and it messed up the frontal lobes of his brain. Before this accident happened, he was a hard worker, got to work early, on time, one of the hardest workers the railroad had. He lived through this, and as you can see, obviously on the right, but what happened, the lobes that were in front of his head that controlled time, judgment, and all were messed up. After the incident, he became lazy. He didn't want to do. He was mean and grouchy. And that's what occurred. As you can see, this is why we study the brain. Our brain, different parts, do different things. The CAT scan, the CT scan, computerized axonotony scan, is what looks at your brain. This is where you have a slice through of your brain and reveals your brain structure. It's basically like you put your brain on a copy machine and made a copy of it, just sliced straight through, looking at it. Okay. An MRI is what is the magnetic fields and radio waves that look at the soft tissue of your brain and seeing the structures within your brain. Okay, the soft tissue part, not the hard tissue, and the bone structures. Electroencephalogram is basically where you have wavelengths that go through the head. And we're going to look more at this when we get to our unit on, or our module and mini lecture on module 8 of sleep, dreams, and body rhythms. But electroencephalogram is basically where you look across the brain and measures your evaluation of your brain function. And a PET scan is a visual display of brain activity. Radioactive glucose is injected into the brain to reveal its functioning. My uncle had a PET scan done when I was in 8th grade. He actually had a tumor in his brain, and they did. Now, he's fine today. They did not have to do major brain surgery. They went in and plugged up the blood vessels that led to the brain. This is actually what will help. I mean, that's what, when you have a tumor, what feeds it and keeps it going is blood. And if you cut off the blood supply, what happens to it? Very simple. It dies. And that's what happened here. A PET scan was what actually found that tumor in his brain. He kept hearing a ticking noise and didn't know what it was, and the doctors found that. Now, the oldest part and central core of the brain is the brainstem. And this is what, as you can see, this is where the spinal cord, it begins where the spinal cord swells and goes in. The brain and the spinal cord are one mechanism. Okay. And that's where the brainstem goes straight in. It's the oldest part, and the brain came from that. Okay, this deals with your survival functions. The medulla, or if you've ever seen the movie Waterboy, medulla oblongata, deals with your basic life support functions, your heartbeat and your breathing. If something's damaged, it can lead to death. But this also controls anger, jealousy, and aggression. The limbic system is what that makes the oblongata part. The limbic system here deals with your fear, aggression, hunger, and thirst, dealing with the mechanisms of the hypothalamus, the hippocampus, and the amygdala. Now, the hippocampus is located in the limbic system. No, I had a student literally ask me one time, is a hippocampus the school where hippos go to in your head? Unless this is 1960 and this is LSD time period, no, that would not be. But this is the hippocampus wraps around the back of the thalamus and processes new memories for permanent storage. The reason why it's named hippocampus is because hippo is Greek for horse, and it looks like a horse. Now you may say, well, are we talking about the four-legged thing that runs around the field? No. What we're talking about is a seahorse. Okay, and that was what back in the old days, that's what they would say. And hippo was the Greek for horse, not a hippopotamus. And a hippopotamus does not look like a horse anyway. Cerebral cortex is what is your body's ultimate control and information processing center. This is where your 30 billion nerve cells are enacted to be able to get the information out there. And this cerebral cortex is divided into 4 lobes. Now, the corpus callosum connects the brain's hemispheres. Yes, you can cut the corpus callosum. And what this does, this is basically, this allows the two hemispheres of your brain to the left and the right to communicate with each other. But it's okay if it's cut. This will be done to prevent seizures sometimes, and it's perfectly fine. They don't have to communicate with each other. They act as separate entities anyway. But this connects the brain's hemispheres, allow them to interact with each other. That's the corpus callosum, and the reason it's called corpus callosum, it looks like a C. The longitudinal fissure is the equator of your brain. It goes from the front all the way to the back and straight down the middle, and it separates the left hemisphere and right hemisphere. Right? And it creates major divisions in your brain. Now, the frontal lobes are the front part of your brain. It's the forehead. This is what Phineas Gage had problems with. Okay? And it involves planning and it involves judgment. The occipital lobe is all the way at the back of your head. This deals with visual processing images of the brain. It's like the concave and convex lenses. And the back of your head deals with visual. That's when if you get hit really hard on the back of your neck, and sometimes you might blank out for a little bit and black out, that's because the occipital lobe has been bruised. And that will occur. Sometimes people who are blind actually knock their head up against, if they're doing something, knock their head, and part of their vision could be restored. It has happened before. Temporal lobes are right on the sides of your temples. If you take your index fingers right now, place them on your temples, right in front of your ear area, and you rub them, that is right on the other side, by an inch in, is your temporal lobes. This is what deals with your auditory, your hearing area, your brain. It's located near the ears. Plasticity is where your brain is going to change, especially during childhood. Your brain will grow and develop. And actually, a child's brain, half of it can be removed and they can go on to live a relatively normal life because their brain is growing. Once you get to be an adult, though, you do that, that's not going to happen. But your brain is growing, especially as a child. That's plasticity, and it can always repair itself. You have left brain and right brain. Those are the 2 types of hemispheres that are in your brain. And they work as a single entity and are taught to communicate with each other through the corpus callosum, but they can be split, and it's okay. The brains don't necessarily have to communicate with each other. For left brain, this is, most people, this is used with your language functions. Some people, it can actually be in the right side of the brain, but your left side of the brain deals with your language functioning, how you speak, how you do, what happens. The Broca's area is in the left part of the brain, and this deals with muscle movement involving speech. You can form ideas, but you can't express them with speech if the Broca's area is damaged. And here you can see the blue dot is actually where the Broca's area is located in your brain. The Wernicke area deals with language comprehension and expression. This is on the left side of your brain too, and that is the red area that you see. And finally, the right hemisphere deals with spatial abilities, being able to judge distance and give in space and make connections between words. And this is our mini lecture on the brain, its different lobes, its different parts, its different functions, and what it does.